Okay, so we are in lesson 9.3, but before we get to lesson 9.3, I want to do a little review of perimeter and area of some basic shapes in case you forgot, because you're going to need them for this next lesson. So let's start with a square. Now, this could be a square where we have both sides the same, or a rectangle, right? Rectangles and squares, you find the perimeter and the area the same way. So perimeter, you're going to add all the sides. So for this one, that'll be 2 plus 2 plus 2 plus 2, right? Because you need to add all 4 sides. For this one over here, that would be 2 plus 4 plus 2 plus 4. For the area, it is going to be 2 times 2. And for this area, it would be 4 times 2. So perimeter for a rectangle or square, if we want to write the formula, is going to be 2 times the length plus 2 times, I'm going to put that in parentheses, times the width, right? For area, it's going to just be length times width. So I would write those down in case you forgot. If you remember, then you're good. Now I'm going to show you for a triangle in case you forgot. Okay, so let's say now we have a triangle. And I'm just going to label these sides A, B, and C. All right, we'll erase that. Now, if I wanted to find the perimeter, remember perimeter is just adding up all the sides. So that would be A plus B plus C. If I wanted to find the area of a triangle though, area of a triangle equals 1/2 times the base times the height. This is the height, right? That in the middle. So I'll give you one with some numbers and we'll try that. So let's say I have a triangle. We'll make this one a right triangle. And let's say I have 3, 2, 5, right? And I want to find the perimeter. That's just going to be 3 plus 2 plus 5. Now, if I want to find the area, the space inside of that triangle, I'm going to take 1/2, multiply that by the base. The base is going to be the bottom. So for this one, that's 2. And the height is going to be how tall it is. So for a right triangle like this, the height is just that side, which is 3. If it were a triangle like the first one, they would probably give you the height in the middle of it, kind of like here. They would have told you what that number was. All right, so that's how you find the area of a triangle. So now that we've got those out of the way, we can get into 9.3. So in 9.3, you are going to be figuring out the perimeter and the area of what we call composite figures. And what a composite figure is when you take shapes that you know, things like rectangles, triangles, squares, semicircles, and put them together to make a different figure of shapes. A two-dimensional shape, meaning that it's flat, right? You're going to need to figure out the area and the perimeter of these. Now, if we just looked at the shape by itself, you've never learned that shape. You've never learned how to figure out the area perimeter of that shape. But if we break it down into the shapes that it's made of, you can find the area and the perimeter of those shapes and then just add them up. So if you look at this first blue one here, you have a triangle and you have a square. So if you wanted to find that area, find the area of that triangle and then find the area of that square, add them together. Now they would need to give you some numbers to do that, but that's the main idea of what we're going to be doing today. So I would definitely write down this vocabulary, maybe these examples. So here's the first example, and this is in your book too, but I'm going to just kind of walk you through it. So here they gave you a grid. They won't always give you a grid, but when they do, it can help you. So it says estimate the perimeter and the area. They're saying estimate because on the shape they didn't actually give you any numbers, so you're just assuming, right? So we'll assume each one of these little squares represents a 1 of whatever that unit is. So remembering perimeter is adding up all the sides. So we can just go up around this whole shape and add up the sides, right? So that's what they did. If you look over here with the red, they counted all those sides and they got 14. If you look over here at the point where the blue is, these are diagonal. So they don't necessarily equal 1. They're not the same length as just one side of the square, but they assume that it's like 1.5. So you add each of those as 1.5, you would end up with 6. So you're 14 from the red, you're 6 from the blue, and you would add that all together, and that'll give you your total perimeter, which would have been 20. All right? So that's how you would do it if they gave you a grid like this. And we'll do another one, but you have this in your book. Use this example to refer back to. If you have a grid like this, all you have to do is count around the sides, but if it's diagonal, count them as 1.5. So now for that same shape, we need to find the area. And remember, area is the space inside. So we never learned how to find the area of an arrow. So let's see which shapes we can break this up into and find that area, right? So since they gave you the grid, you could just kind of count. You don't even really have to do the multiplication. So you know they marked it in the red. You count all the full squares that you have, right? So there were 12 full squares, so there's 12 right there. Then you have all these half squares. That's the blue. You have 4 of those half squares, these guys right here. And you have 4 halves, which 4 halves, if you add them up, it's going to be 2. So you take the 12 from here, right? Add that with the 4 halves from here, and that would give you a total of 14. So if they give you a grid like this and you're asked to find the area, all you have to do is count, right? So we're going to get to, if they gave you numbers, how to find it. But right now, all you need to know is if you have a grid, you want to find the perimeter, count around, count the slants as 1.5. If you're trying to find the area with a grid, just count the squares on the inside, and the ones that are half filled, count them as a half. So now let's try to do one together here. Looking at this shape, let's first start by trying to find the perimeter of it, right? So all we have to do is add the sides of the grid. So I'm going to start with the straight ones because I feel like that's easiest. So starting here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know I have 12. Now the rest of these are all diagonal, and we said we were going to count those as 1.5s, right? So how many 1.5s do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to add 8 times 1.5 to my 12, right? And 8 times 1.5 is 12. So I'll end up with 12 plus 12, which would be a total of 24 units, because they didn't tell us if it was centimeters or inches or anything like that. So that would be the perimeter of that shape. Now, what if I want to find the area? So if I want to find the area, remember that's going to be on the inside. So all we have to do is count how many whole squares we have on the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Plus, how many half squares do we have? Right? So we have 1, 2, 3, 4, 5, 6, 7, 8 half squares. So we'll add that to 0.5 times 8. And I use 0.5 because 0.5 is a half. You could also have written it as 1/2, right? So 0.5 times 8 is 4. So 12 plus 4 would give us an area of 16 units squared. Because remember I said the units for area are always going to be squared. All right, so that would be the area for that one. So now let's see how we do these if they actually gave us some numbers and not a grid. All right, so this is another one in your book. This is the figure that they gave us, and they want to find the perimeter and the area of this figure. So looking at this figure, you're kind of like, what is that? But you notice you have a triangle here and you have a semicircle here. So you can find the perimeter of that, and you can find the area of those two shapes, right? So first, let's start by finding the perimeter of this shape, okay? So first thing we need to do is let's start with this circular part. What is this circular part here? What is that? So we know that if we find the circumference, it'll tell us the distance around the whole circle. So let's find that circumference and then just divide it in half because it's half the circle, right? So circumference is pi times the diameter, and you see that here. So they did 3.14 times 10 and divided it by 2, which means that we had 15.7. 15.7 is that curved part. Now all we need to do is add that to the 8 and the 6, which is 14, which would have given us a total perimeter of 29.7 feet. So you see what they did? They added up the two sides and then added up that semicircle there, which is just half the circumference, okay? Okay, so now looking at our shape, if we wanted to find the area of it, we know we have a triangle here, so let's find the area of that triangle. And remember, I gave you that formula at the beginning. In case you forgot, they put it here for you again. So that's going to be 1/2 times the base times the height. The base on this triangle is 6 feet. The height is 8 feet. So we end up with an area of 24, and we're going to add that to the area of the semicircle. Remember, the area of a circle is pi r squared. You should have that in your notes. Write it down again in this section if you feel like you'll need it. And since it's half of a circle, though, we're going to take that area and divide it by 2. So pi times the radius squared. The diameter is 10, which means the radius would be 5. So 5 squared times pi, then you divide that by 2, would give us an area of 39.25. Add those two numbers up, our total area of this shape is 63.25 square feet. So now I'm going to give you a word problem we're going to work through together, and then we'll be done here. So let's say that we have this pool deck, and 1 gallon of wood stain covers 200 square feet. How many gallons of wood stain do you need to cover the deck? So that's just the wooden part. We need to know what's the area of the wooden part. And then we can figure out how many gallons of stain we need. So to figure out the area of the wooden part, let's look at the shapes we have here. Well, we know this is a triangle, so we can figure out the area of that triangle, right? And we'll add that to the area of this square, but we also need to subtract the area of this semicircle from that, right? So first, let's start by finding the area of the semicircle. So area of semicircle. And we know that that's going to be pi r squared divided by 2 because it's half of the circle. So 3.14 times half the radius of this circle, because it's 26, would be 13. So 13 squared divided by 2 would give us 169 times 3.14 divided by 2 would give us 265.33. All right, so that's the area of our semicircle. Now let's figure out the area of our square. So area of square. So the area of our square is just length times width, which since this is a square, 26 times 26, right? Which is 676. So now if we want to figure out the area of this part in the middle here, we subtract the semicircle from the square because we don't need the semicircle part. That's part of the pool. So 676 minus 265.33 would give us 676 minus 265.33, 410.65. And we're going to need to add that to the area of the triangle. So let's figure out what the area of the triangle is. Area of triangle. And remember, area of the triangle is 1/2 times base times height. So that'll be 1/2 times 10 is the base, 24 is the height, 0.5 times 10 times 24 would give us 120. So go ahead and add that to your 410. So 120 plus 410.65 is going to give us our total area of the deck. So we're almost there. Now we know the total area of the deck, but it's asking how much wood stain do we need? So if we know we have 200 square feet in every 1 gallon, we can just divide, right? So take this number, divide it by 200. What do we get? About 2.7 gallons. All right? So that is pretty much 9.3. Basically, it's taking the area and the perimeter of those different shapes, putting them together. I gave you this last one because it's kind of a harder one of where you would have to actually do some subtracting too if you wanted a certain amount of space, but that's pretty much it. You know how to do all the math, it's just putting it all together. There you go.